Until this lesson, we weren't really focusing on validation inside of our RESTful API. I mentioned validation here and there. I showed you the problem details response on a couple of occasions, but we didn't pay too much attention to it. So we're going to fix all of this as part of this lesson. We're going to focus exclusively on validation inside of our REST API. We're going to focus mainly on input validation and safeguarding our business rules to some extent. And we're going to see how to report validation errors back to our API clients. For this, we're going to use the problem detail standard. So there will be two main focus areas in this lesson. The first one is defining our validation rules for the incoming requests. I'll show you a couple of alternatives. Some are built into ASP.NET Core, and some are available through external libraries. Secondly, we're going to see how we can standardize returning our validation errors back to our API clients using the problem details standard. But what is problem details? The problem details standard is more closely defined by the 9457 RFC, which is called problem details for HTTP APIs. A problem details represents a standardized error format that you can return from your REST API. This is what the problem details JSON object looks like. It also comes with its custom media type, which is application/problem plus JSON. The contents of this type is a JSON object similar to this, where we have a type property describing the specific error. Then we have a title, which should be short, human readable, and describe the problem in more detail. Then we can have a detail, which can be a longer description, helping the client figure out what went wrong. The instance field should reference the specific instance of an error, and then you can also include any number of extension properties on the problem details response if you think they will be helpful for your clients. I'm going to leave the link to this standard right below this video if you want to check it out. And now let's move into our code and see how we can approach validation and returning problem details responses. I'm going to start our discussion about validation and the problem details error format from Postman, and I will send a request to obtain a tag that doesn't exist. And when I send such a request, I get back a 404 not found response, and the JSON object that you see in the response is the problem details format. You can see the type property, which is a URL that if I click, I will be navigated to the HTTP semantics RFC, and it points to the not found HTTP status code. The type value will change based on the response status code. It also contains a title, not found, the specific status code value, and a trace identifier that we can use to find this specific trace inside of our distributed tracing platform. Other than the response object, if you take a look at the response headers, you can see that the content type is application/problem JSON. So there is also the correct media type present in the response headers. Now let's move our attention back to validation. I have a simple post request for creating a new tag inside of our system. And we already have some level of validation in place. If, for example, I were to try to send a null value for the name and the description, and I send this request, I will get back a 400 bad request response with an additional property in the problem details. This property is called the errors, and inside of it there's an error for the name property, stating that the name field is required. If we take a look at the create tag DTO, which is what we are binding this value to inside of our controller, you can see that the name property has a required value in front, and I'm also specifying string as the type, as opposed to a nullable string. And this is actually nullable reference types working for us when it comes to binding the input objects. We are referencing this type inside of the create tag endpoint on the tags controller, which also has an API controller attribute. And this gives us some level of validation right from the start without us having to do anything. Now, what if I slightly change the request? For example, instead of specifying a null value for a string, I just specify an empty string. And if I send this request, it's going to end up creating a new tag, which is obviously not a valid tag instance. We don't want the name to be empty. So what can we do about this? Inside of ASP.NET Core, there is a very simple validation model that we can use for something like this. It relies on using attributes, and the attribute I want to use is the required attribute, and the namespace that you want to reference is the system component model data annotations. You can use this to define that a particular value is required. Other than the required attribute, there are a lot of other useful attributes that we could use, like the minimum length attribute. And let's say that the shortest value that we allow for a tag is 3 characters. Now I can also have a maximum length attribute where I want to define the max length of the description to 50 characters. Now this may or may not be different to the values that you have inside of your database. It's not what I'm necessarily concerned with. I just want to show you how you can achieve simple input validation using the data annotations attributes. So with the changes in place, let's start the application and let's try sending the same request to our REST API. This time, you will see that we are getting back a 400 bad request, and it says that the name field is required. There is also an additional error message that says that the field name must be a string or an array type with a minimum length of 3. So if I were to include, let's say, 1 and 2 here and send this request, the required error message is gone, but the minimum length error message is still present. It's only until I specify 1, 2, and 3 that this request is now successful. Now let's focus on the description. Let's say I specify a description value, which I'm going to just randomly generate by copying this a couple of times, and this should be at least 50 characters long. And now if I send this request, I'll trigger the validation for the description data annotation, which has a maximum length of 50 characters. And as expected, we get back an error saying that the description field has a maximum length of 50. So this is how you can implement some simple input validation rules. Just introduce some data annotation attributes on your properties and you are good to go. However, this approach is limited to some extent. Other than the available set of attributes that you can use for validations, that's pretty much it. If you want to implement something more complex, especially dynamic validation rules, then you are on your own. Now, you could try implementing a custom data annotation attribute, but I don't think this approach is particularly scalable. So I want to show you a more powerful approach. There's a very popular validation library called Fluent Validation, and let's go ahead and install it. If I search for Fluent Validation, I'll be greeted with a couple of options, and then the question is, which library should you use? There is the base Fluent Validation library that contains all of the abstractions that you will need. There's the library with support for dependency injection extensions, and then there is the ASP.NET Core library. Now, if you take a look, this hasn't been updated quite recently. The last version was released in 2023, which is almost 2 years ago at the time of recording this video. Inside of this library, there were some automatic validations that you could implement, which are no longer recommended. So I will install the dependency injection extensions library only. It already references the base library, so there's no need to install both of them. So let me install this one. And then let's go back to the create tag DTO and let me show you how to define a validator. So all you have to do is implement another type. Let's make it a class, and I will call this the same name as my DTO, and then append validator. Then I'm going to implement the abstract validator base class and use the create tag DTO as a generic parameter. And then I need to define a constructor where I can define my validation rules using the available methods for defining my rules. So let's say I want to define a rule on the name property. I need to select it, and then I can append what is the requirement that I want to enforce. Let's say that the name must not be empty. I can also add a minimum length rule by specifying minimum length, and let's say that the minimum length is 3. And then for the description property, we can select the description and we can say that the maximum length is 50. So we are mimicking what we already had using data annotations. Now obviously this approach with the Fluent Validation library is much more verbose than using simple attributes. However, it opens up a lot of options with these validation rules that you simply cannot match using the attributes. I'll show you a more complicated example in just a moment. The next question is, how do we use our validator? So if I go back to my controller and we focus on this endpoint where we are creating the tag, what we could do is create a new create tag DTO validator instance, and we can call the validate or the validate async method. But remember that I installed the Fluent Validation library with support for dependency injection. What this will allow us to do is to register our validators as services inside of the application. So for example, let's say right after configuring the controllers, I will say builder services add validators from assembly, and I need to specify an assembly where I can find my validators. There's a different extension method that allows me to use a generic argument and specify the implicit program type, which is the current assembly basically. And if you want to make your validators internal, make sure to set the include internal types flag to true. Now, because my validators are not, I can go ahead and simplify this by omitting this argument. Now, what does this allow me to do? It's going to scan my current assembly or any implementation of the iValidator interface, which is what is behind the abstract validator class, and is going to register them with dependency injection. And then we can just inject it inside of our endpoint. So I can inject an iValidator, specify my DTO, the create tag DTO, and assign this a name. What I'm doing here is called method injection because I only want to inject this validator in the create tag method, and I don't necessarily need it in all of the endpoints inside of my controller. So now that we have the validator instance, we can call validate or validate async. There's also validate and throw, which is going to throw a validation exception if we run into a problem. So let's say I go for the validate async approach. I need to pass in my DTO, await this, and I will get back a validation result. So then if the validation result is not valid and I need to negate this condition in front, then we can